a really bad code base, and when you have a requirement change, you're going to get, oh, I need to modify 20 classes in order to change a single line. Awesome. That's going to be great. Yeah, so unfortunately, we have to think, at the same time we are delivering good stuff, we have to think about making a reliable, scalable, and maintainable code. And for that, I'm going to be talking about some patterns, some architectures, and some, well, ways to test them so we can get that goal of really usable code, really reusable code and maintainable code. I know we all have code bases that are really, really old. So in the ideal world, I will say throw away everything and start again, but that's impossible. So all the things that I want to show you here in this talk, you can reuse it. You can use it in your code base. Just, you know, when you are doing a new feature or you are touching an old feature, just try to apply one of those patterns that I want to show you. But before going into that topic, let's get into fragments. I said I was not going to be talking about fragments, but I lied. It's just going to be 5 minutes, okay? It's going to be really quick, real quick. You know, fragments are really good, like really. It's a component that Google built in order that we can reuse functionalities in different screens. So it encapsulates full features, you know, and then they are awesome and they are coupled. You can use them with loaders and async tasks, and they all need the context, and it's real great. Right, it's what I call burrito design pattern. So listen, this came up. I was eating a burrito, and I have this thing. I love everything burrito. I just wanted to put the GIF here. I think this GIF is one of the best in the history of the GIFs. So I love burritos. I love burritos, but I have a problem, right? And it's a DNA problem. I cannot stand cilantro. It tastes like soup, like soap. Sorry, soap, which is different. So it tastes like soap. It tastes really bad. I didn't know this because in Spain, where I am from, we don't eat cilantro, so I didn't know it. And then I went to my 23andMe, and after a year eating cilantro and didn't know what was happening to my body, it says, well, some people from Europe has this issue with cilantro. And I was like, really? Okay. So why I'm saying that a fragment is like a burrito? Well, so when I go to order a burrito in the farolito and they put cilantro on it, I have a problem. I just can't eat it. So how they are going to take out the cilantro? Well, they cannot. They have to build another burrito because everything it's coupled together. You know, it's always, you know, in that awesome tortilla and stuff, but it's all coupled. So that's the same problem that happens with fragments. It couples everything together, and when there is a requirement change, you just have to change the whole thing going on the fragment. So, you know, it's good for reusability, but it's not good for decoupling your business logic from everything else. That's one of the cons of the fragments, but there is another one. Yeah, you probably love this. So this is the official documentation of the state machine of the fragment. But in reality, it's more like this. Actually, it's even worse because it depends on the activity. Yeah, it's a complex state machine. You know, why you do this to me? Seriously, like, I know you are super smart, but I just want to build stuff, you know? I don't really want to know 20 life states. I don't have that many years to understand them. So, yeah. So, I mean, you are totally fine using fragments. Just you will get used to the fragment manager and all this stuff and the life cycle and blah, blah, blah. But you can just, as professional Android developers, you can do your own, right? Because what is the goal of the fragment? The goal of the fragment was to reuse that piece of code in different screens, right? So you can do the same by just, you know, having a single activity with a navigation manager, or having many activities with reusable views. Because let's think about it. What you really need in an Android application in order to show something on the screen? The context. That's it. Everything goes around the context. So what you can do is just abstract everything, have an entry point where the context is, and then you can inflate layouts whenever you need them. So this is the idea that I was talking about. We have we need an activity because otherwise there is no application that we're going to learn. We need an activity because we want to show something on the screen, right? So we have that activity, and then we're going to have that navigation manager, and it could be as simple as having a URI. And each screen is going to be one path of that URI. So we are starting the application, we start the screen number 1, the navigation manager inflates that screen, and at the same time adds that path to the URI, and then we just got it on the screen. Then the user interacts with that screen, and that starts the screen number 2. The launch activity is gonna just get that event, and it will just, the navigation manager, append that and start the new screen. It's as easy as that, okay? So you can use fragments, but you can use your own stuff. That's why we are professional developers. But we are done with fragments. Let's start about the real deal. So let me explain you how to develop like a pro, and for that, that's me, yeah. Let's make an app. Actually, I have an app, I have a code, I have a repo, an open source repo with all the things that I'm going to show you today. So you are more than welcome to fork it, submit PRs, and enjoy my code, maybe. Yeah, so this is the application. You know, you log in with Twitter. I work at Twitter. So you use Fabric for easy login. It gives you the API client too. And then I show the most retweeted links on your timeline. And when you click one, then it shows this web view, which is really bad UI, but it's a demo, okay? So then you have the drawer layout, and then it shows the same. Top images, the most retweeted images in your timeline. That's it, that's the application. So let's start with, I'm still going with the demo, okay? Cool, yeah. So let's start with one advice. This is my advice. Try to decouple all the implementation, try to decouple your app from implementation details. And by that, what I mean is, if you hide the implementation by using a contract, an interface, what you get is that you can change the implementation details, but the classes, depending on that contract, they're not going to be changed. Unless you are adding a new feature, but then that's normal, right? So in that application that I was showing you before, I need an image loader, right? So the image loader could be an interface like this. It loads a URL into an image view. And I don't really care how my team or I implement that. I just care that I need that functionality. So in this case, you can use Picasso, or you can use Glide, or you can use Fresco, or you can just do your own thing. It doesn't matter. That's not going to change anything using the image loader construct. So that's my first advice. My second advice is, let's talk about the common UI, because most of the applications have common UI. Nice sound. Let's keep going. So in this case, I have as common UI the drawer layout and the toolbar, right? So we should be able to reuse that and then just inject the content in the part of the screen that we want. For that, we can use another contract, screen container contract, and it's as easy as bind an activity and return a view group that is going to be injected, right? And then get drawer layout because we want to show it and we want to use it. In this case, what you can do is you can have an effect. I actually have an effective activity, which is an abstract activity that all my activities extend on. And there, on the onCreate, what I'm going to do is exactly that, is binding that activity. So I'm setting the content view for the common UI. And then I'm going to inflate that get layout, which is the abstract method that I'm going to implement in all the different activities. So in that section of the screen, what I'm going to inject is the proper layout for each different screen. Right? Bind, inflate, and the abstract method. So now let's talk about patterns and architecture. So we are going to start with MVP, and then we are going to continue with clean architecture. If you have questions, you can keep it for the end. If we don't have time, we can do it offline. Let's start with MVP, that stands for Model View Presenter. So, you know, how does this work? Well, you have a view which receives the user interaction. That notifies the user, that sends the call to the presenter saying these interaction happened, And the presenter is going to call the model and requesting the right data that the screen needs to render. The model is going to be working on that and deliver that entities to the presenter, and the presenter will probably create another different type of entities that the screen can render in the screen. So I'm going to deep on the code so we understand everything. The key here is that each of those layers, 3 layers, they have one responsibility. The view only knows how to update and modify the UI, the things that appear on the screen. The presenter only knows what business logic model method calls when that event happens. And the model only knows where to get the data, process that data, and send it back to the presenter. So the presenter is kind of a proxy. The model is the business logic, and the view is just updating the UI. So in this case, for this activity, the top images, what would the MVP look like? Well, the view, in this case, I'm adding interfaces. You don't really need them. I'm just adding them because it's easy to see the API. So in this case, I only really need to set a list of images. Those images is just a pointer that holds the data that I really want to show the screens, which was the number of retweets, the URL, and some things like that. So in this case, the view, it's implemented by the activity. Remember that the responsibility of the view, it's only to update the UI. So it's implementing this method, and in the method what we are just doing is setting that content into an adapter, and then that will show the images on the screen. Think about it, if we decided, for example, to not use the most retweeted the most retweeted pictures, but we want to use the most favorite pictures, most liked pictures, we change that, then nothing is going to change because the view is going to be, the image is going to still be the same. What is going to change is the model, and we'll see that later. Yeah, the logout, we don't want to keep them logging forever. They have the right to log out, so we do the logout. And then we are calling, as you can see, there is a presenter initialization, and we call onCreate, because when the onCreate happens, we have to render something in the screen, right? So let's talk about the presenter. The presenter is really simple too. In this case, the application is simple. It's just going to be create and then set view. We need the set view. I will explain you why we need the set view, especially to avoid memory leaks, but we'll talk about that later. So as you can see, the presenter has a view, and then it has a model because it needs to reference both and call them both. It's the proxy, is the man in the middle. And then we're going to have a list of views. Can you imagine why? Well, the presenter is going to be the one keeping the state of the screen. So when there is a configuration change, we can reuse that list of images. We don't need to call again the API or get the data again from the database. It's just there. We just load it once, so we don't want to do the same work again and again. And that's exactly why I have in create that if that view images is already there, just call back to the view with that list. Otherwise, model, give me the most retweeted images. And here is the thing. We need a weak reference. Otherwise, we're going to provoke a leak because the view is implemented by activity, and in case that is destroyed, the presenter is going to be still holding that. So that's what we have. I implemented weak callback. There is a better way to do this without the callback that I will explain you at the end of the talk. But this is good enough. This will stop the memory leak. Of course, you have to do some if null, don't do anything. But that's better than leaking memory. So let's talk about the model. The model is pretty easy. It's just one call. In this case, is get most retweeted images. What are you trying to do here? Well, what I'm trying to do here is I need the data first, right? So that's the client, the custom API client that I have. Then Those parameters, ugly parameters, is the API, the Twitter API. I just have to use it like that. And then I have that process tweet. The arrow is a little bit down, but it's pointing to process tweets. Process tweets, which is doing is, I don't really need tweets. What I only need views, which is like the model, the entity that I use in the screen to render that recycler view. So that's what it's doing. It's processing those tweets and changing them to the other class that the view understands. So the responsibility is clear. It just gets the data and parses it to the right entity objects. Think about it. If we decided to use tomorrow another API, it's not going to affect the presenter nor the view. It's just going to affect the model. So again, this layer allows us to change requirements fast. Of course, if there are new requirements, then we have to add new code, but that's okay. What we want to be flexible is with all code that we want to make behave different. Okay, so now let's talk about test. That's your favorite part, of course. So just one thing. I wasn't born with a skill to write test, but neither write code. So it's a muscle that you build. And you want to build it because I like to sleep at night. That doesn't mean that my code is not going to break, but if the test is passing, I'm going to be, I want to have a peace of mind. So why? Because what I'm going to test is the business logic, so I know that the process tweets, in that case for the model, is going to be working correctly, that the interaction between view, presenter, and model is going to be working. Of course, it can break because for that you need interaction. I was talking about unit tests, but you need integration test and then UI tests, which UI tests are really pain in the ass, but they are really helpful. So we need to test. How are we going to test that? Easy. So the view, we are going to mock the presenter, and we are just going to test that is modifying the Android, the UI properly. The presenter is going to mock the view and the model, and we are going to test the interaction between presenter, view, and model, and then that when certain event happens on the view, it's calling the right event on the right method on the model. And for the model, you just test the business logic. You don't test the connection to the API. If the connection to the API fails, well, maybe the server is failing, I don't know, but maybe it's the API client. Hopefully nobody broke that layer, that network layer. So that's it. That's how we test this. It's kind of simple, actually. Try to do that with a fragment and call me if you are able to do it. Okay, so it has some pros, It has 3 layers that allow you to have 3 different responsibilities, and they couple them. So when you have to change one of the layers, usually you don't have to change the other one, the other 2s. And of course, let's think about it, right? So we are using a recycler view, but what happens if I have to change it for a list view? Probably I don't want to do it because recycler view is way better. But if you want to do it, you just do it. You just go to the view and you change it, and nor the presenter nor the model needs any change. So the same if you change the API for a database, or if you change the Twitter API for another API. It only affects on the model. And the presenter, it's affected when there is requirement changes. When on create, we don't want to show the list. We want to let them choose, for example, a topic that they want to see, the most retweeted pictures, right? But that's like a huge new feature, so that's okay. There is cons, of course, nothing comes for free. There is boilerplate to wear up the layers, of course. And then at the end, model and view and presenter, they are super tied to one use case. So you don't really can reuse them a lot. You will need extra layers of separation and decoupling. But we'll talk about that on the clean architecture. But for now, let's talk about oriented changes or configuration changes. How you do that? Well, as I was giving you the hint before, the presenter is going to hold the state of the screen, or the data that the screen needs to render again. So for that, we just have to remember how the activity lifecycle works. What we are going to do is on the onCreate, and I have the code for all of this, so you can check that out later. On the onCreate, we're going to go to the presenter holder, and we're going to say, hey, do you have a presenter for this activity? If you have, then give it to me. Otherwise, then I will just start to give, I will instantiate a new presenter and do it again. And then what we know is that when there is an orientation change, it goes to the onSafe inside state method. At that point, we are going to save the presenter in the presenter holder But of course, we want to check if on the onDestroy, the activity is finishing. If it's finishing, we want to remove the presenter from the presenter holder, because we know that that activity is not coming back anytime soon. So you can do this implementation in two ways. One that I don't recommend. I mean, yeah, of course, you can do whatever. I mean, you can implement all the business logic of your application in the application class if you want, and make it static. It's going to be fun. But so just don't use the application for everything. Okay, so don't do that. It's an easy way to do it, but don't do it. You can do this. You can do a presenter holder, which is a singleton. Spoiler alert. Yeah, don't use singleton. But in this case, we are only keeping those presenter holders for a short amount of time, and they are not changing any behavior. You know, the presenter holder is not changing at all. So it's just data for me. And that's how you implement it. It's really easy, and it works. You can even do it better in the future, and you can persist that on the database. So when the user exits from the application, but it starts again, you can even show the state before they exited the application. They're going to be like, whoa, what happened here, right? Because usually they don't expect that we are keeping that state. Cool. So that's how it works. That's how the presenter holder works, and you can wire them up. You can put it on the view, on the activity, on the onCreate. You get the presenter for that activity. Then you save it on the onSafe instance state, and if it's finishing, you remove it. You don't want to keep that there forever. Cool, let's talk about clean architecture. I hope you are enjoying this MVP, but now let's get, fragments is like a burrito, clean architecture is like a bento. It's, all really good food, all really nicely packed. They don't touch each other, They all work together really well for your taste. Right, so we are going to do the bento of the architecture, the clean architecture. So you can read this long article about it from Uncle Bob. I mean, I think it's really interesting that he never got into how implemented. So it's more like a theory. I think it's fine. You can read it. It's really interesting. But that was, so after reading many people how it's implemented that on Android, I think this is what I like the most. We are actually using some kind of version in Twitter now, and it works pretty well. We don't have the domain layer, which I'm sad about it, because I really like the domain layer. But let's get to the insights of the clean architecture. So the presentation layer could be the VP part of the MVP, and with a twist, of course. You see the view entity that I will explain later, and then the domain layer is going to be the use cases. And then the data layer is going to be the repository. It's like, just give me the data. Give me the data that I need for, do my business logic, and then send it back to the presentation model. So it's actually like a kind of an MVP, but with two more layers, right? Yeah, add as many layers. It's like I don't get the name now. Lasagna, right? Lasagna, right? You can put more layers, right? And it's better, and a lot of meat. Okay, so presentation layer. So it's like VP with a twist, and the twist is the view entity. We are not going to persist the presenter anymore. The presenter could be bigger in complex app. A bias. If you have a complex UI, you can divide that UI in different presenters, in a smaller MVP, so you don't get big presenters. But you don't want to persist the presenter too much because it could be big. But the view entity could be just the state of the screen, meaning is that edit text with some string. If it is, just store it on the view entity, Is that enable or disable, then store it as a boolean, and then you match those views with that state. So it's like a POJO. That's it. And in orientation changes, you persist that view entity. It's the same idea, but this time only with a POJO, really small POJO. Now let's talk about interactors. I like interactors. They handle one use case, and it's one single. Try to maximize, and for maximize the reusability, try to put just one use case. For example, in that application, we have this. We have the get top articles, right? But get top articles could be even more smaller. At the end, what we are doing is getting some data sorted in a way that I want to render it. So what we are sorting it is sorting by retweets. So that one I can actually create as a unique interactor use case and then reuse it with the other screen that I have in pictures. Okay? So that's the cool of the interactor. It's like a mathematical function. You get an input and you get an output. You apply something on that input and you get an output with the expected. And the cool thing is if you are, I really like to make them super small, so that's why I call the method execute. I'm forcing myself to do one single thing, and the documentation will be the test, of course, but the name of the interface. So what I'm doing is get to particles. That's it. So this is the implementation. This is not actually really interesting, but you can see I'm using the Twitter repository that I'm going to explain you right after this. Repository. Okay, so repository, we say we have the model, which is the business logic, and then is retrieving the data from somewhere. Actually, those were two different responsibilities. One is retrieving data from somewhere, and another is having the business logic, which means process those tweets into the images that we want to show. So that's the repository. The repository knows where to get the data from the different data sources that you can have. You can have a database, you can have an API, you can have a cache, right? And then the interactor is going to call that to get that input that has to modify and send it back to the presentation layer. Cool, so this is the tweet repository. It has get timeline and get tweet, right? Because that's what we want. We want to get the timeline, and then we're going to process those tweets and get the most retweeted images and links. So it's going to be as simple as that. That's really cool. And think about it now, super simple, it's just an API. But what about if tomorrow I want to have a cache in memory so I don't have to keep doing that, I don't have to keep making requests all the time. And what about if I want a database where the user can actually do some kind of action like put this retweet as my favorite, right? So that will be an action that I want to store in my database. So that will be all the changes on the repository. That's only the responsibility of the repository. So that's it. That's a clean architecture, right? Easy. Presentation is decoupled from the main. Interactor is just a function that gets an input and returns an output. It could be a Java module. If you don't use anything that Android is providing to you, it could be even a Java module into your Gradle project. That's amazing, right? That means that you can actually test it easily. And then you can reuse it too. You can reuse it between different apps. And then the data layer, the repository, decouples the rest of the app from any change in data sources, and it just knows where to get the data from. It could be a Java module too if you don't use any Android SDK component. So that's another pro. At that point, what happened is what I'm saying. Like, you get into this thing and say, okay, let's add more layers, right? Let's add like 20 more or whatever. I don't know. Let's just decouple everything. Everything is an interface, and take it easy. Don't do it, because that's what happened. We like to make complex things. You remember fragments? Yeah. Sorry. So let's do over engineering. It does. So you have to be really careful. And there is even more boilerplate than before because there is more layers, right? So for that, there is this library that launched a few months ago that actually implements the clean architecture and give you the base classes for your views, for your domain, and for your repository. And they use Dagger, so then you don't have to do the boilerplate wiring the different layers. It's actually really good, and it's a company that is using that in all their projects. It's a consulting company, so I recommend you to check it out. It's open source. One more thing. So callbacks are really not powerful at all. It's just anonymous classes, strong references, blah, blah, blah. They don't give you any power. The power comes when you put RxJava on it. You get, actually, if you were here for the LU talk, that was perfect example of what is the power of RxJava. And that's what I'm doing, actually. That I'm changing all the callbacks to observables. Why? Well, because I get the scheduling, I get the back pressures, I get the operators. And for a simple application like that, doesn't make too much sense. But imagine you have an application that in a screen you need like call two different API endpoints, and you have to combine that data. And at the same time, you have to combine that data with a database. So doing that with callbacks is going to be a callback inside a callback. And with Direct Java is a really fluent API that you can read and you understand what is going on, and then it allows you to schedule in one thread in another super easy. And it gives you observables, that notion of a stream of data. So listen, Direct Java is great. The concept of reactive is amazing. I don't know why we forget it for so many years. So check it out. You probably all know about this. And the last but not least, I want to quote myself, which is terrible, but this is what I want you to know what I think about our position. We're doing social, I'm doing social apps, okay? But people has their phone almost 24 hours in the hand. Even when they sleep, they put it in the nightstand. So test your code. Be sure that your code is solid. Be sure that it's delightful, because otherwise you are affecting those people's life. So just think about it. I want to give thanks to some people that helped me, and you can get the code in that Billy link. And if you have any question, you can send me an email. We can talk offline now. And I think we have time for questions, maybe, I don't know. Let's try it. See if you have questions. Yeah, go ahead. He was first. Sorry. Again, Google gives you a lot of really good components. You are the one that should make the call. If you think the pros are more beneficial to you than the cons, then go for it. Right? So personally, I don't like to add logic into the XML, because that remains to GSP or something like that, and I don't want to remember that. But you're free to use it. I mean, whatever Google does is awesome. They are the best engineer or really talented people. So if you want to use it, it's good. You had a question too, sorry.
How would you handle the history between the views, like the backstack between views in this application? Have a map that users put in URIs, or?
So it depends, right? If you want to use one activity, then you need a class that handles that navigation for you, that stack for you. Yeah. And that could be, what I was showing you, the URI and append path. And that path is actually the name, the unique name of that view, and then you know what is going on, right?
Re-inflate the view again, the back view, or just catch that previous view, for example?
Right, that's a good question. So there's always have to be performant. So that means if you try to not reinflate it, it's going to be better. It depends on how expensive in memory is, though. So you have to have always that balance, like when they were talking at the beginning, the keynote, Chet and Romain, like if you think about what they do is we catch stuff, we do things ahead of time, so it's faster, but at the same time, you need the balance of we have a memory limit in the device, right? So yeah, depends. But I will try not to reinflate a view that I'm going to be using soon. Go ahead, please. So what I was saying, the network, so the question was, in case you want to do a network call, in what layer of those architecture that I was explaining, you will do it. And that will be the model or the domain layer or the repository. So that's like the last of the layers. That's only going to be there, yeah. And you want to do that, of course, in a worker thread. You don't want to do it in main thread, of course. Yeah, so the repo actually, the repo there, it has that example and it shows you how to make that network call in what layer. Any more questions? We can talk offline if you want. Okay, thank you for coming.